class. So what I'm going to be doing in this video is going over an additional bonus example problem where we're going to try to find a labor supply curve. So you don't have to watch this video, this is not required, but if you'd like to get a little bit more practice or see one of these problems work out, feel free to watch along. So in this problem, I'm giving myself the following information, right? I have 24 hours a day, which I can use to either work or engage in leisure, and I receive a universal basic income of $20 regardless of how much I work. So that's going to tell me essentially what my options are. The other side, I've got my preferences. I have something that looks kind of like Cobb-Douglas utility function, except that I have a subsistence constraint where I need at least 4 hours of leisure per day or I die. So as a consequence, I'm going to end up, instead of just 2ln L plus ln C, my preferences are going to be represented by 2ln of L minus 4 plus ln of C, right? So if I've got less than 4 hours of leisure, this is going to become negative infinity. And my goal is going to be to find my optimal supply of labor. So first things first, what are we looking for when we look for supply of labor? Well, our first objective is going to be, I'll know that my labor supply, which I'll call curly LS, is just equal to 24 minus my choice of leisure, right? And I'm going to say actually curly LS of W, 24 minus my choice of leisure as a function of W, right? So I can figure out my labor supply by finding optimal choice of leisure as a function of the wage, right? Note that we're not being given a wage here. The reason is we want to know how much this person's going to work at any given wage. So this is our goal. Now, how are we going to go about finding our optimal choice of leisure? Well, what we're going to do is we're going to solve a standard optimization problem. So in order to do that, in order to set that up, we're going to need two things. We want to be able to understand our preferences, right? What we like better than everything else. We also want to know our options, right? What we can afford, what we can't afford. So let's start with that second piece. Let's start with our budget constraint. So what's our budget constraint going to look like? Well, the easiest way to think about labor supply, leisure and consumption budget constraints is to think about how much consumption I could afford for a given choice of leisure. So how much consumption can I afford? Well, it's going to be the amount I get from working plus the amount I would get without having to work, right? So what would I get from working? I would get my wage times the amount of time I spend working, which is going to be 24 minus L. And how much do I get without working? I get this $20 in non-labor income. Now this doesn't really look like a budget constraint to me, right? It looks a little bit unfamiliar, so I'm going to transform it by adding W times L to both sides. That's going to give me WL plus C less than or equal to 24W plus 20. Essentially what we're saying here, right, is that our total consumption or total spending on goods, right, our goods of leisure consumption, has to add up to less than or equal to our total income. The total income is the value of our time, that's the 24 hours times W, plus the value of everything else we own, right, which is our $20 universal basic income. What's this going to look like graphically? Well, if I put leisure on the horizontal axis, consumption on the vertical axis, how much leisure can I afford if I spend all of my time engaging in leisure? I can afford 24 hours of leisure, right? Why not more than 24 hours? Because there's no way for me to turn time into an even longer day, right? There's a certain point when the sun sets and the situation's over. If I spend 24 hours engaging in leisure, I can afford 20 units of consumption, right? So this is where my budget constraint is going to start. Then how about if I get as much consumption as possible? Well, in that case, I'm going to get my 20 units of consumption for my UBI plus 24W, right? 24W plus 20 is going to be my maximum consumption. Budget constraint is going to look like that. The slope of this thing is going to be the price of leisure over the price of consumption, which is just going to be W, right? We can see that wage is the price of leisure, 1 is the price of consumption. Beautiful. Okay, so this is my budget. Now that I've got my budget, I just need to know my preferences, then we can find my optimal choice. So I have a utility function. What am I going to do to make sense of this thing? I'm going to try to find an MRS, right? So step 1 was budget constraint. Step 2 is going to be my MRS. in terms of leisure and consumption, which is going to be du dl over du dc. Okay, great. So what's du dl? If I take the partial derivative of this thing with respect to L, what am I going to get? Well, the derivative of a log function, right, if I had the ln of x, it would be 1 over x. Using the chain rule, I'm going to say that the derivative of L minus 4, right, ln of L minus 4, is going to be 1 over L minus 4. And then what's du dc? This is going to be, oh, I'm sorry, times 2, right? So it's actually 2 over L minus 4. And then du dc is just going to be 1 over c. So therefore my MRS, ln c, is going to be, right, if I multiply both things top and bottom by c, I'll get 2c over L minus 4. Beautiful. Does this make sense? Well, what's this telling us? It's telling us that the more consumption I have, the more consumption I'm willing to give up for another unit of leisure. Right? Remember, my MRS is telling me how much consumption I'm willing to give per unit leisure. The more leisure I have, the less consumption I'm willing to give per unit leisure. And then I've got this minus 4 here, right, because I'm only really going to start valuing being willing to trade leisure once I have at least 4 hours of leisure, right? So the first 4 are just getting me up to the point of being willing to make any sort of decision at all. So far, so good. We've got a 2 here. This makes sense because I place more value in leisure than consumption. So if I had the same amount of leisure and consumption, I'd be willing to give up more than a unit of consumption for leisure. Okay, great. So here's our MRS. What do we do with this thing? Well, next thing we're going to want to do is consider our possible choices, right? In particular, could we have corner solutions? So let's think about each of our corners. Is it possible that we would choose the corner where we have all consumption and no leisure? Well, in that case, right, if we look at our MRS, we would end up saying that our MRS would be 2 times our level of consumption over 0 minus 4. We're going to end up with a backwards MRS because of the fact that essentially it's not possible for us to ever choose less than 4 hours of leisure. So no, this corner is not going to be possible. How about our horizontal corner? Well, in our horizontal corner, right, we would end up with 20 units of consumption, 24 hours of leisure. We're not going to get an infinite MRS here or a 0 MRS here, right, because at this corner, we're still going to be able to get some amount of consumption. Right, we have an MRS of 20 times 2 divided by 24 minus 4, which is not going to be obviously lower or obviously higher than our price ratio. So our horizontal corner could exist. Right, and the reason for this is that even though we have something like Cobb-Douglas preferences, we're not going to have 0 consumption at our corner. So our horizontal corner could exist, and our interior solution could also exist, right? We have an MRS that does depend on how much of the 2 goods we're consuming. Okay, great. So I'm going to start by looking for this horizontal corner, right? Now that we know that a corner solution can exist, let's figure out where the corner solution could exist. So what has to be true in order for us to have a horizontal corner? Well, we're going to need to have an MRS that's steeper at the corner than the price ratio, which is W. Right? We need an MRS greater than W. It's going to mean that 2C over L minus 4 would have to be greater than or equal to W. Now, this has to be true not just for generic C and L, but for the C and L that I have at this corner, right? So this is going to tell me that 2 times 20 over 24 minus 4, that would be greater than or equal to W, which is going to mean that W would have to be less than or equal to 40 divided by 20, which is 2, right? So what this is telling me is, if I have a wage less than $2 an hour, I'm going to decide not to work at all, right? Great. Okay. So now I know what I'm going to choose. If I'm at a horizontal corner, I know what wage rates are going to lead me to be at that horizontal corner. last thing that I need to do now, in order to find my optimal choice of leisure, is to find my interior solution, right? What happens if I have a wage greater than or equal to 2, where I'm going to choose to work? Right? If wage is greater than or 2, I'd have a leisure choice less than 24 hours, right? And so I'm going to have an interior solution. In that case, what has to be true? Well, to have an interior solution, I would need to have my MRS equal the price ratio, right? The slope of my indifference curve has to equal the slope of my budget constraint. And I'm going to need to spend all of my money, right? So I'm going to need MRS equal to W and WL plus C equal to 24W plus 20, right? So let's start here. So I'll say 2C over L minus 4 has to equal W, right? Which is going to tell me that C has to equal W times L minus 4 over 2. Note what I'm trying to do here is find one of my variables, right? One of my choices in terms of the other choice for any given W, right? If we knew the wage, we would know the consumption as a function of leisure. Then I plug this in right over here. So I'll say WL plus W times L minus 4 over 2 has to equal 24W plus 20. This makes sense? So now I can simplify this. I'm going to bring all of the L terms together and bring everything that doesn't have an L in it together. So I'll say 3/2 WL minus 2W has to equal 24W plus 20. Right? Now I'm going to bring over this minus 2W over to the other side. Remember, for any given value of W, this is just going to be some number. I'll say 3/2 WL is going to equal 26W plus 20. Then I'm going to multiply both sides by 2 over 3W, right, to get L by itself. And that's going to be 2 over 3W times this, 26W plus 20. That is going to simplify to, well, the first piece of this here, right, is going to be 26W divided by 3W times 2. So 26 times 2 is 52 divided by 3. Right, W over W is nothing. So this is going to be 52/3 plus 20 times 2 divided by 3W. So that is going to be 40 divided by 3W. Okay, great. So at this point, we've done all of the work, right? We've found our answer. So we've said that if W is less than or equal to 2, L is going to equal 24. Right? If W is greater than 2, L is going to equal 52 over 3 plus 40 divided by 3W. So I'm going to take all of this together. I'm going to mush it together into a single piecewise function. I'll put over here, right? So I'm going to say L of W is going to equal 24 if W is less than or equal to 2. It's going to equal 52/3 plus 40 over 3W if W, this should be a less than or equal to, that's not super clear, if W is greater than 2. Now, a couple things we want to check here. We want to make sure that this answer makes sense. Let's say that we have a W exactly equal to 2. We should get that that's going to be both a corner and an interior solution. Right? Our MRS should be just equal to the price ratio. We should be able to choose exactly 24 hours of leisure using this equation. So if W is equal to 2, this would become 52/3 plus 20/3, which is 72/3, which is 24, exactly as we should expect. Wonderful. A couple other things to check. Does it make sense that as our wage is increasing, right, well, first of all, as our wage is increasing, are we choosing more or less leisure? As our wage is increasing, we're choosing more and more and more leisure, right, because we're dividing this thing by W. The second chunk here is getting smaller and smaller and smaller. The reason that this makes sense is that with Cobb-Douglas or Cobb-Douglas-like preferences, we're essentially spending the same fraction of our income on leisure and on consumption at every level of wage, right? Now, as W is increasing, our income is increasing, right? This piece is increasing, but the $20 that we get from the government is making up a smaller and smaller share of our income, right? So spending about 2/3 of our income on leisure is going to mean that leisure is going to shrink over time, right? Because essentially the value of our time is going to become a more and more important component of our overall income. So that's also going to make sense. Okay, great. Now this got us to our optimal choice of leisure. Our ultimate goal was the supply of labor, right? So I can say that labor supply as a function of W is just going to equal L of W, it's going to equal 24 minus L, right? All of the time that we don't spend engaged in leisure is time that we're going to work. So that's going to tell me labor supply as a function of W is going to be here, 24 minus 24, so 0 if W is less than or equal to 2. Over here, we're going to have 24 minus this whole thing. So what's 24 minus 52/3? As we said before, 24 is 72/3. So 72/3 minus 52/3 is 20/3 minus, right, this piece here, 40 over 3W. If W is greater than 2. And that is our final answer. Okay, beautiful. So I've kind of gotten it all on the board. I'm sorry if this is a little bit hard to follow, but I'll also post solutions if you'd like to take a look at this. Hopefully this is going to be helpful to you. Okay, wonderful. Thank you for taking the time. Looking forward to talking to you in real life.